Bullet ant. What it is. The bullet ant, Paraponera clavata, is a solitary hunter from Central and South America. It's not technically a soldier in the colony sense, but it's the most painful ant on Earth, and that's its entire defense strategy. How it works. Bullet ants don't swarm. They're solitary foragers, which means they need a weapon that works alone. That weapon is venom, specifically a neurotoxin that triggers pain receptors for up to 24 hours. When it stings, it feels like being shot, hence the name. The Schmidt Pain Index, a scale that rates insect stings, ranks the bullet ant at a 4.0+, the highest rating. Entomologist Justin Schmidt described it as pure, intense, brilliant pain, like walking over flaming charcoal with a 3-inch nail in your heel. People who've been stung report pain so severe they can't move for hours. Takeaway: if you ever encounter one in the rainforest, don't touch it. The sting is a last resort, but it's absolutely devastating. The ant is actually docile until provoked. It's the venom that does the talking. Trapjaw ant. What it is. Trapjaw ants, Odontomachus species, have the fastest strike in the animal kingdom. Their mandibles snap shut at speeds up to 145 miles per hour, faster than a bullet train. How it works. Their jaws are held open by a latch mechanism. When sensory hairs on the inside of the jaw detect prey, the latch releases, and the mandibles slam shut in milliseconds. The force is so extreme that it can also launch the ant backward if it needs to escape danger. They literally catapult themselves. The snap is so fast that it creates a shockwave in the air. Scientists discovered this by filming them at 40,000 frames per second. The acceleration is around 145 gr. That's 145 times the force of gravity. For comparison, a fighter pilot experiences about 9 gr during extreme maneuvers. Takeaway: imagine a mousetrap, but alive, armored, and fast enough to catch prey mid-air. That's the trapjaw ant. It's a pure ambush predator. It sits still, waits, and executes with mechanical precision. Army ant. What it is. Army ants, Eciton and related genera, are nomadic raiders. They don't build permanent nests. Instead, they form massive colonies that march across the forest floor like a living army, consuming everything in their path. How it works. Army ants are mostly blind, so they navigate using pheromone trails laid down by scouts. A single colony can contain millions of workers and soldiers. The soldiers are larger, with bigger heads and mandibles, and they protect the column as it moves. They're not defending a nest, they're defending the march itself. A single army ant raid can kill and consume thousands of insects, spiders, and small vertebrates in a single day. The colony moves every night, and when they do, they form a living bivouac, a temporary nest made entirely of their own bodies, linked together by their legs and mandibles. It's a structure that dissolves and reforms every 24 hours. Takeaway: imagine a river of ants, several meters wide, flowing through the forest. Anything in the way gets overwhelmed. Army ants are nature's cleanup crew and nature's nightmare, depending on your perspective. Leafcutter soldier. What it is? Leafcutter ants, Atta species, are farmers. They don't eat leaves. They farm fungus on them. The soldiers are the largest caste in the colony, and their job is pure defense. How it works. Leafcutter soldiers are massive compared to workers, sometimes 10 times heavier. They have oversized heads and mandibles, but they're not great at cutting leaves. Instead, they ride on the backs of leaf-carrying workers and protect them from parasitic flies. It's a symbiotic relationship. The soldier gets a free ride, the worker gets protection. Leafcutter colonies can contain up to 5 million individuals and span multiple chambers underground. The fungus garden is so sophisticated that the ants have evolved antibiotics to prevent contamination. They farm bacteria that produce antifungal compounds. Humans have studied this for potential medical applications. Takeaway: a leafcutter soldier is basically a tiny tank with a big head. It's not the most aggressive ant, but it's built for endurance and protection. If you see a line of ants carrying leaf fragments, the big ones riding on top are the soldiers, and they're working. Honeypot ant. What it is. Honeypot ants, Myrmecocystus species, have soldiers with a bizarre adaptation. They're living storage tanks. Their abdomens swell to the size of grapes, filled with honey and nectar. How it works. Honeypot ants are found in arid regions. During times of plenty, foragers bring nectar back to the colony. Specialized soldiers, called repletes, hang from the ceiling of the nest and store this nectar in their distended abdomens. When food is scarce, workers come and tap the replete's abdomens, and the repletes regurgitate the stored food. It's a living pantry. A single repletes can store enough food to feed dozens of workers. Some honeypot ants are so swollen they can't move. They're permanently attached to the nest ceiling. Indigenous peoples in Australia have eaten honeypot ants for thousands of years. They taste sweet and are considered a delicacy. Takeaway: imagine being so specialized that your only job is to hang from a ceiling and be a food storage unit. It's weird, it's efficient, and it's one of the most alien things in the insect world. Weaver ant. What it is: weaver ants, Oecophila species, are arboreal architects. They don't have soldiers in the traditional sense. Instead, they have major workers that are aggressive defenders and builders. How it works: weaver ants build nests by pulling leaves together and sewing them with silk produced by their larvae. The major workers are the ones that do the heavy lifting and fighting. They're not venomous, but they're incredibly aggressive and will swarm intruders. They also farm aphids for honeydew, which they protect fiercely. Weaver ants can coordinate complex group tasks. A single leaf might require dozens of ants working in synchrony to pull it into position. They communicate through touch and pheromones, and they can solve problems that would require planning in larger animals. Some researchers believe they have a form of collective intelligence. Takeaway: weaver ants are the engineers of the ant world. Their nests are intricate, three-dimensional structures woven from leaves. If you ever see one, don't touch it. They bite hard and swarm instantly. Dracula ant. What it is: the true Dracula ant belongs to genera like Adetomyrma and Mystrium, found primarily in Madagascar and other tropical regions. They earned this name due to an extremely unusual behavior. They feed on the hemolymph of their own larvae, the insect equivalent of blood, without killing the young. How it works: workers delicately pierce the cuticle of the larvae and drink small amounts of hemolymph. Afterward, the larvae recover. It is an efficient form of nutrition within the colony, allowing adults to feed without destroying the next generation. Scientists call this non-destructive cannibalism. Some related species also possess ultra-fast mandibles used for hunting and defense. In certain cases, these are among the fastest movements ever recorded in the animal kingdom. Researchers found that some species of the genus Mystrium can snap their jaws shut at extreme speeds with staggering acceleration. Other species in the Dracula group have drawn attention for their vampiric behavior with larvae, something virtually unique among ants. Imagine entering a colony where adults feed on their own larvae without killing them, while close relatives use lightning-fast jaws as biological traps. It is a reminder that evolution finds solutions as strange as they are brilliant. The Dracula ant doesn't win through brute force. It wins through efficiency, adaptation, and strategies that seem straight out of science fiction. Exploding ant. What it is: exploding ants, Camponotus species, specifically C. saundersi, are Southeast Asian suicide bombers. When threatened, they literally rupture their own abdomens to release a toxic chemical spray. How it works: exploding ants have specialized glands in their abdomens filled with a sticky, toxic secretion. When a predator or intruder threatens the colony, a soldier will contract its abdominal muscles, rupturing the gland and spraying the toxin everywhere. The ant dies, but it takes the threat with it, or at least damages it enough that it leaves the colony alone. The toxin smells like curry. Scientists discovered this by accident when studying the ants and noticed the distinctive smell. The chemical is a deterrent, not a lethal poison, but it's effective enough that predators learn to avoid colonies of exploding ants. It's a form of altruistic suicide. The soldier sacrifices itself for the colony's survival. Takeaway: this is nature's ultimate defense mechanism. It's not aggressive, it's a last resort. An exploding ant would rather live, but if the colony is threatened, it will literally blow itself up. It's grim, it's effective, and it's one of the most extreme examples of colony-level cooperation in nature.